All right, so we'll start off with opening a brand new project for this. We just have a Chapter 11 project. And with this one, unlike some of the others, I'm going to keep this all in one map because steps 1 through 3 all pertain to the same analysis, all the way to number 4. And so I'll start a new ArcPro project, and I'll just call this Chapter 11 Exercises. Exercise problems. And I'll put it in the put it in my C drive in the 273 in chapter, and then I'll make it chapter 11 folder here. All right, so exercises for chapter 11. Okay, so remember that one of the things that she wants you to do is set your environments. So we'll want to set those environments right off the bat. The first GIS layer that we bring in is going to set the coordinate system for this. And so she wants the data to come from the Black Hills and then the Sturgis geodatabase. So we can go ahead, what we need to have first is the vegetation density layer. So we'll have to find what layer she's talking about there. And so I'm going to go ahead and add that first layer. We'll set the environment second. So for this, we'll go to the MGIS data, and this is going to be in the Black Hills folder in the Sturgis geodatabase, and we're looking for something that has to do with vegetation. Now, so if you remember the icons in the catalog or when you're adding data, remember if you see this icon here, these are all raster data. So there's a canopy layer, a land cover layer, and a topography layer. And then we have features again being vector data, points, lines, and polygons in this feature data set. So let's take a look. If I remember correctly, the vegetation one is going to be a polygon layer. And so one thing I like that she does in this exercise set is she's mixing vector and raster data. So we know at some point all of this converts over to raster. We have a raster solution. But that doesn't mean we only have raster data as input to it. You can have vector data as input to a raster analysis. And we'll see how that works here. So we'll add the vegetation layer. It's going to zoom us into the Black Hills area. And if I zoom out on this map, we can see how the Black Hills fits, how this National Forest area fits within the Black Hills. That's what this is showing us. And this is the vegetation types. Now, if we go back to our problem as it is, she wants these two conditions. She wants this to become a Boolean. So all we want to think about with Boolean is that the output from this is going to have values of zeros and ones. So nothing fancy. That's what Boolean's all about, is just zeros and ones. And we want it to be where the density 96 is B or C, and the land is owned by the Forest Service. We need to look at the attribute table to see which of those attributes we can use to make the map the way we want it. All right. I'm going to bring this up a little bit so we can see the attribute table. If I open up the attribute table for the vegetation layer, we're going to be looking for the owner type is here, and we want the ones that are National Forest Service, NFS probably. And then we want something with that vegetation 96. I think there it is, density 96, and she wanted codes. Let me just zoom in on this. Sorry, my bad, guys. Let's see. So we've got the density 96 and then the owner are the two attributes that we want to be queried. So right now, no features are selected. We can see that here 0 out of the 2,000 polygons are presently selected. Remember, everybody, how you would make a selection, of course, by attributes is you would just go up to the Select by Attribute tool up here. And then we want to set this up. It has to meet both conditions. So we want the AND qualifier between them. Those polygons that get selected are the ones that meet the various conditions here. So let's start off with just selecting the owner type first. And the owner is equal to, and then it's going to be National Forest Service, because this is the choice here is NFS for National Forest Service, or PVT would be private lands. And so we don't want the private lands, we just want the National Forest lands. If I was to click OK on this one now, it shows all those areas that are public property, and then leaves unselected the areas that are private property. So, okay, so of that now, 1,888 of those polygons are selected, leaving the rest of those few hundred unselected that are private property. Now, we want the density 96. Let's look at our example here. Let's go back up to 1. We want B or C in this particular case. So now, there's a few different ways we could go about this. We want to get rid of anything that's other than B or C. We want to get rid of the A's, we want to get rid of these zeros, and so forth. So we can do a select by attributes again, and we have some choices on how we're going to go about this. You know, one of the easiest ways that I would go about doing this is I would right-click on this one and then just kick this out as its own layer. I'd go to Selection, and then make a layer from Selected. And this selected one now are only those ones that are owned by the Forest Service. We're just starting from that set. And now from there, we only have to trouble ourselves with selecting the ones that are B's or C's. And so we can go back to Select by Attributes, where the vegetation selection, those are only the ones that are National Forest Service. And then we want the clause here to be the density 96 is equal to B. And then we can say add a clause. And we don't want and, because you'll never have one that's B and C, so we want it to be or, where the density 96 is going to be equal to C. So if the density 96 is B or it's C, it's going to get selected. Otherwise, it'll leave it unselected. We'll click OK. So now of those, we need to open the attribute table for this to see it. Now of the 1888 total options, there's 1,200 of them that meet those two criteria. So now of her criteria, now we've got it down to the ones that are highly forested and the ones that are owned by the National Forest Service. All right, but we also have to create a Boolean out of this. The simple way to create a Boolean out of this is we just do a conversion from vector to raster. And there's various tools to do this, but there is this whole set of tools in the raster functionality that's just these conversions. Now, when you convert from vector to raster, it doesn't have a cell size in mind. It doesn't have any information like cell size or the extent, so we have to give it that information. And that's where she wants us to set our environment settings. So I'm just going to go back. Let's take a look at what she wants. Before we do this next step, we need to take a look at what she wants for that. So she wants in our environment settings, set the cell size to 30 meters and the extent to default. Reset the environment settings. Also verify that the snap raster and the mask are not set. Okay, you do that. So, in order to get to those environment settings, you'll learn this in the tutorial if you haven't a chance to see this yet, but they're in the analysis ribbon, and then there is environments as one of the options up here. So let's just see what that looks like when we click on environments. So the environments are set for your entire project. This isn't for one tool, this isn't for one map, this is for your entire project. So everything will adhere to this after this point. So let's see, the output coordinate system, she doesn't say anything about that, but the extent she wants to leave it at default, but then the cell size here, she wants us to change this to 30. And so that's where the only parameter we need to set in there. Okay. So now we need to find the right tool to do that conversion. And so I'm going to go back to my toolbox. Raster to feature, or you could do raster to polygons. Polygon to raster is the name of the tool. And it's just in the conversion toolbox. Right now we have a polygon layer. By the way, when you run this tool, if some of your features are selected and some are unselected, only those selected ones will become, will meet the criteria and come along as raster. Everything unselected will not. So let's go ahead and click on, we'll get that tool. The input feature that we'll use for this is going to be our vegetation select. And it's warning me right now that there's only 1,200 of those polygons are selected, and that's exactly what we want because all 1,200 of those meet those two conditions, forested and owned by the Forest Service. The output raster data set, let's go ahead and I'll click on the browse button here. We want this to go into our geodatabase for chapter 11, and this is going to be step 1. This is going to be forest, and remember this is a raster name, so we want to keep it relatively short and no spaces. Forest, and I'm going to put in National Forest Service, so it meets those two criteria. Also, this is going to be 30 meter in the end, so I sometimes like to have a little code to myself. This is going to turn into raster data where the cell sizes are 30 meter on a side. Okay, so back to this. It's asking for the cell size here because our environment was already set before. It pulls in that number. And then I'm going to go ahead and hit run. So this is going to make a raster version of the polygons that met those two criteria, and that'll show up in this map layer over here. So there it is. There's something a little strange going on. If this happens to you, just go to the symbology, and we're just going to change this to single symbol. It doesn't have to have all of those unique colors. So let's put it to discrete, and it should. Let's change that to. Oh, I know what I did wrong. Ha. Okay, so what I did something wrong. Let's go back to that tool real quick. I used the wrong field for the name. So if we look at the different attributes for this one, I think the default that it wanted to use was object ID. So for it has 1,200 or 2,000 different classes of data in this because of the way that I set that up. So I'm going to run that tool one more time. Get back into it here. So the input for this is our selection. It's this one right here that we want to change. And I'm just going to change this one to owner. That's going to be the simplest. It's going to make them all National Forest Service. We will, for shorthand here, I'm just going to put a 2 behind this. Whenever I make a mistake, I always just have a 2 so I can distinguish the most recent one. But I just want to show you why this is an important step right here. This value field, as it is, because the default there was object ID, and every single one of those almost 2,000 polygons each have their own unique one. It's a sequential number. It was trying to make a raster that was keeping track of all those different parts. And that may be important for some applications, but not for this one. And so I switched it to owner here so that anything that's National Forest Service owned will all be lumped together. This is going to make a discrete raster rather than a continuous raster. Everything else should be fine. I'll run it again. My first clue that it didn't go right is because I had that really, really long symbology type, so I'm just going to remove that one while we're waiting. Wait, what did I end up removing? Did that finish? Okay. We just add that in. All right, so it's in here. Chapter 11, and it's this number 2 that we want. Okay, so it's just values of 1s. Let's just see if this actually worked. I have to turn this off to see it. Honestly, I'm not seeing it. Something's going a little funny here for me. To admit. Let's let's see, I don't want this stretched, I just want it to be, there we go. Or we could change it to unique values. It all should be the same. So in this case, it's black's not a great color for this. Maybe like a green color would be a nicer one. Something like that. Okay, so there's the areas that met both of those conditions of being owned by the National Forest Service and also being forested. So right now, this is not still yet a Boolean. A Boolean will have values of zeros and ones. And so there's one more step that we frequently use when it comes to making Booleans, and it's a step called reclassify. And if you guys remember from our that example we used for the myelin bottoms, we took all the different soil types, and then we just did it for just those soils that are highly erodible. And then we took all the different land uses, and we said, we reclassified that whole thing into zeros and ones. Remember, we're like anything that's non-ag, we did 0. Anything that was agriculture, we did 1. In this case, we're going to reclassify this layer into where anything that says National Forest Service, NFS, will have 1. Anything that's non-NSF will be a 0. And so we need to run one more tool here. Go back to geoprocessing, and that tool is going to be the reclassify tool. The input raster for this is going to be the only raster we have, and that's National Forest Service data. The owner is going to be our reclass one. So the way this is set up right now, remember with the land use example, there were 23 different types of land use, and we were lots and lots of them went to 0. Water went to 0, urban areas went to 0, treed went to 0, and then ag went to 1. In this case, National Forest Service is already going to go to 1 in our output, but no data. Everything in between is also going to stay no data unless we change this. But we're going to change the no data on the new side to a value of 0. So this is going to make a Boolean now, and this is the output. This is the layer that we want to come out of step number 1, where this is anything that's a 1 meets both of those criteria. It's got the right vegetation, and it's National Forest Service land. Anything else will be a 0. So I'll go ahead and we'll rename this output layer, not to reclass, but this is going to be step 1 result. And hopefully there won't be a step 1 result 2. That means it's something messed up. So in the end, let's see. It still doesn't look any different. Everybody see how this, but in order to actually see this, we have to go to symbology and then change this from owner to value, and now we should see zeros and ones, and now our entire map. This is what a Boolean looks like, is where there's 2 shades of color, and then you would have the 2 output values would always be zeros and ones. So that's going to get us, this is the Boolean output that our textbook author is looking for, a map that looks like this. Anything that's green met those 2 criteria, anything that's blue did not meet one of the 2 criteria and are excluded then. The beauty of this is that, let's just say, and I had a GIS project a few years ago from a student who was looking at 10 different parameters with Boolean, and then in the end, when you do a Boolean overlay, if you do a multiplication, just a simple multiplication, it has to hit a 1 across all of them. So, if you ever are multiplying, you hit a 0 at any place, the output's going to be a 0. So if it had to meet all 10 criteria, you would do your first layer times your second layer times your third times your fourth, all the way to 10. If at any raster cell it hit a 1 for all 10 of them, the output's going to be a 1. If it doesn't, if it hits a 0 at any point, it might have met 9 conditions, but it hit 1, 0, the output's going to be a 0. Exactly right. So then, in the end, you have a Boolean output that just shows the areas that met those criteria. All right. So that was all of that was step number 1, and what I'm going to do, that took us 19 minutes